Hi, everybody. I'm Bob Bowman, Editor-in-Chief of Supply Chain Brain, and I want to welcome you to this special presentation on innovations in supply chain planning and optimization. First, in a six-part series of webinars on the theme of creating resilient supply chains through IT innovation, presented by Deloitte. Today, we're going to talk about network optimization and digital twinning. Leading companies are adopting new strategies to prepare for the next inevitable disruption. One is the creation of digital twins that can simulate critical supply chain elements such as factories and warehouses, as well as entire supply chains and ecosystems. It's the next major advance in how companies can make the most of their existing analytics tools and data. With that, I want to introduce our speaker for today. He is Thomas Boykin, Specialist Leader at Deloitte Consulting, LLP. Thomas is a leader in Deloitte's supply chain and network operations practice with over 28 years of industry and consulting experience in helping manufacturers and consumer products companies improve the performance and profitability of their logistics and distribution functions. His areas of focus include network strategy and design, transportation, and inventory optimization. So with that, I'd like to turn it over to Thomas Boykin. Thomas, take it away.
Thank you, Bob. Hello, everyone. Great to be with you this afternoon. Wanted to talk about digital twinning. And just to set the stage, I want to share with you what the agenda is for our time today. So I'll share some insights to put some context around why we believe this area of supply chain digital twinning is so important. Then I'll share some thoughts about the use of technology regarding data and the fact that because of the availability of prevalence of data and advances in technology, there's a great opportunity to leverage this technology to address some of the challenges we're facing today in the supply chain. Then I'll talk briefly about the evolution of supply chain simulation. I'll give a couple of examples about how simulation has been used in the past, and then we'll quickly go to the topic, which is digital twinning. We'll define it, and then we'll talk about why we believe it's the next frontier of supply chain simulation. There'll be a discussion that Bob will lead, and then we'll give you an opportunity to ask some questions and answers. So, for context, Deloitte for the past 9 years has been working with MHI, which is Material Handling Industry Trade Group, to develop and publish a survey of supply chain executives regarding supply chain innovation. And what we're focused on is their level of adoption of that innovation. We've tracked about 11 leading technologies over these 9 years, and we've noted certain trends in terms of the level of adoption. So those technologies that we consider to be leading are cloud computing and storage, sensors and automatic identification, RFID, voice, barcoding, etc. Inventory and network optimization, which is the subject that we're covering today, robotics and automation, predictive and prescriptive analytics, industrial Internet of Things, 3D printing, wearable and mobile technology, autonomous vehicles and drones, artificial intelligence technologies, and finally, blockchain. If you take a look at the stats that we're sharing, the dark blue bar indicates the current level of adoption of each of these technologies. But more importantly, the light blue bar indicates the degree to which the supply chain executives expect to be using this technology within the next 5 years. And for context, this area of network optimization tools, technologies related to that, are projected to be the leading technology used within 5 years, or actually over the next 5 years. Critical data point. Keep that in mind as we talk about supply chain digital twinning. Another key stat I wanted to share was that in the survey we probed about what are the biggest challenges that these supply chain executives are facing? What keeps them up at night? And this year, for the first time, supply chain disruptions and shortages rose to the top of that list. In previous years, talent, competition for talent, which in an environment of a labor force that is getting older and retiring and becoming driving shortages has been top of mind. And that still is a critical concern, as we all know. But this year, for the first time, supply chain disruptions and shortages rose to the top of that list of what's keeping these executives up at night. And that's not surprising, given what we've experienced over the last 2 years. But another area we probed on is the expectation that there will be other disruptions. We're not even through this one, but clearly there will be more disruptions in the future. Another area we probed on is what are some of the strategies that companies are using to address the challenges that they face. So some of the traditional strategies, as you might expect, are in the category of kind of flexible manufacturing supply chains, making their supply chains more flexible. Things like using traditional kind of cost management, cost containment strategies to address some of the challenges, and traditional, approaches to recruiting, retaining, and reskilling workers. But these age-old strategies are not enough, is one thing we found, to ward off the impacts of the next disruption. Leading companies are adopting new technologies focused on increasing visibility, transparency of the supply chain, and more importantly, increasing the resiliency that's going to be needed to recover from the next disruption. So one of these strategies that's starting to emerge, and by no means are we suggesting that this notion of digital twin simulation is prevalent. It is on the leading edge. However, it is becoming more and more a go-to strategy for some leading companies. And that's the next level, using the next level of simulation technology to build digital twins that can help companies simulate individual supply chain elements, such as factories, warehouses, or even warehouses within a network of warehouses, or even automation within a warehouse of networks, network of warehouses, but also developing a twin of entire supply chains and entire ecosystems. And that's really what we're here to talk about today. Another point of context is the trend that the physical is becoming more and more entwined with the digital. And that's an observation that many of us have made and are making. The world is becoming more digital, and definitely the supply chain is becoming more digital. The convergence of this physical to digital worlds and the interplay between those two present significant opportunities, especially relative to this topic of simulation. Another trend we want to talk about was the data revolution. It's becoming more prevalent. There's more data upstream and downstream of supply chains. For example, sensors and automatic identification technology is able to capture signals downstream of supply chain and transmit those almost instantaneously back up the supply chain. But the prevalence of this data alone is not going to be enough. The observation we made in the white paper with MHI is that while the data itself is important, it's not enough. It's just the first step in the evolution of insight. First comes the data, then comes with proper context, making that data information, and then further through analytics comes knowledge and insight, and finally action. And the key takeaway is that the full value of the data is only realized when it results in enlightened action, which is key to our discussion today. So just to frame traditional optimization, has focused on defining decision variables that must be modeled or simulated, and it's bounded by certain constraints. And there is an objective function or collection of preferences of an organization that is the outcome. That is really the purpose of developing a model or simulation, to be able to bake into that simulation some variables, to be able to constrain those, and to optimize the decisions and the choices around those variables with a model. Traditional methods of doing that are pretty widely known. So there's dynamic programming that has a way to, in a serial fashion, be able to iterate through some of these choices. There's network flows that are a little bit more complicated, more circular in nature. And then there's linear and nonlinear programming mathematics that's typically applied in order to drive the balance of the constraints against the objective functions. And then there are heuristics that are baked in to simplify the problems and also make those more solvable in real time. A real world example, typically, when many people think of network modeling, they think of a traditional problem of having a series of customer locations that must be satisfied by warehouses or distribution centers. And those warehouse and distribution centers have to receive product from sources, either plants or in some cases suppliers. Sometimes that's regional plants and suppliers. Sometimes that's international, and therefore imports are required. So basically the traditional modeling approach has been to gather information about the customers. Where are they? Who are they? How much volume do they demand? And put that in context of what products that they demand, and then flow back through the supply chain to determine where those sources of product are logically or optimally in order to flow to customers on a cost and service basis. So for a given level of service, what is the minimal cost required for the distribution network to fulfill that demand? And that's the traditional network modeling. And there's a lot of that still going on. So by no means are we suggesting that that practice of traditional network modeling or even of simulation of individual material handling systems or automation systems are becoming obsolete. Those are still going on, much needed and adding much value. However, what we're finding is that the scope of these traditional modeling exercises is being expanded. And for us, that is the topic that we're discussing, which is digital twin. So what is the definition of a digital twin? There are many. One that we will use as active definition for this discussion is that a digital twin is a virtual model of a physical product, process, or an ecosystem. And in our case, we're focusing on the larger ecosystems that are being modeled and the opportunity that companies have in modeling those. So why model? Digital twins enable the simulation of those elements and make it possible to analyze and optimize operations and test potential solutions in a virtual world at digital speed with minimal risk. That is the key, and also allows companies to anticipate the next disruption, and more importantly, to be able to scenario plan around how to be resilient, how to recover from those disruptions. So twins help leading companies proactively identify the problems before they occur and to develop and test new solutions cheaper with less risk of existing operations. The advantages, again, proactive identification of the problems, faster, cheaper development of testing of new solutions, and ultimately dramatically improve supply chain performance and efficiencies with less risk of failure and downtime. Again, I mentioned that the scope of a traditional network model might have been confined to a distribution network. What is the optimal distribution network to serve customers at a given service level, or might have even been confined to manufacturing capacity optimization. If I have the option of building new capacity, where would I build it? Or if I wanted to move product lines around, where would I do that? And traditional simulation has been more, let me simulate a warehouse operation that I'm designing so that I can specify the right automation and buy it in the right quantities. The definition that we have for digital twinning relative to supply chain is that the scope has been broadened and it's looking backstream, more upstream, not only to sources like plants or even tier 1 suppliers, but conceivably tier 2 suppliers, tier 3 suppliers, all the way through to customers. Critical components to be able to do that. Obviously, there's multiple functions of supply chain that must be involved: product development, planning, sourcing, manufacturing, logistics, and distribution. And then there's advanced technologies that will be important to be able to do some of this, like the industrial Internet of Things, where the source of the data is becoming more and more sensors that are placed along the supply chain. There's also data science and algorithms that must be a part of the solution. Machine learning is becoming more a part of it. And we'll talk about why artificial intelligence will be a key component of supply chain digital twins in the future. There's also video and spatial analytics. So it's not enough to have the data and the math. We have to be able to present that in ways that people can really understand. And again, in terms of the infrastructure, again, network optimization, traditional network optimization is a starting point, but we have to supplement that with artificial intelligence, even smart warehousing automation, which will be the topic of the second webinar in this series. Predictive analytics, prescriptive analytics, not only looking forward what is likely to happen, but what should I do about what is likely to happen? Robotics, process automation will also be important, and of course, there's a talent element as well. The reason that artificial intelligence will be needed is that, quite frankly, quite simply, the complexity goes up exponentially when we expand the scope of the traditional supply chain simulation or the supply chain digital twin. That complexity is going to need next level mathematics and also supplemented by artificial intelligence with the algorithms themselves adjusting over time based on patterns that have been observed. And again, the reason we believe this is the next frontier is because the level of tools, the techniques, the solutions will need to be integrated across a single platform as opposed to across silos. That level of integration is emerging. There are companies or providers who are seeing this vision and building their platforms in an integrated fashion to be able to go across data sets and go across functions in supply chain, go across organizations to be able to gather the information and make it actionable across those multiple links of the supply chain. All right. So the key theme of what I'm saying, and we'll summarize here and switch to our discussion, is that next level supply chain problems will require next level solutions. This is, we've seen unprecedented disruption, but there are many lessons that we've learned from that. We should apply those. Supply chain's been in the headlines for not so good reasons, but at least people are beginning to understand the strategic importance of supply chain. That is becoming more and more clear. And leaders have never been in a better position to drive impactful, lasting change. And we're encouraging folks to kind of explore the power of that next frontier of simulation, which is digital twinning.
Geodis is one of the fastest growing third-party logistics providers in the US, managing supply chains for some of the most well-known brands globally. Thanks to its complementary lines of business, including supply chain optimization, freight forwarding, contract logistics, distribution and express, and road transport, Geodis offers clients a unique skill set at each step of the supply chain. With a network spanning 170 countries, Geodis provides customized end-to-end solutions to help clients overcome their logistical constraints. Visit geodis.com. John Galt Solutions, software as a service-based Atlas planning platform, unites efficient planning across your entire multi-enterprise business. Our innovations in supply chain planning technology, combined with decades of domain expertise, uniquely position us to help guide your digital transformation journey. It's time to solve for today's most pressing challenges and continuously evolve to be ready for what the future may hold. Learn why Mars, Continental Tire, Milwaukee Tool, and Organic Valley turn to John Galt Solutions to power their digital supply chain. Visit johngalt.com. And here we move into the panel discussion part of our presentation with Thomas Boykin. Thomas, thank you for that excellent presentation that set the table for our discussion here with a very good description of just what a digital twin is and how it can be of value to supply chains today. But I want to start out by asking you this. We all know that the concept of network modeling and simulation isn't new. It's existed in various forms over the years. What exactly is the difference between the traditional modeling and simulation and digital twinning?
The main difference is scope and complexity. So in the past, simulation has been confined to an individual element within a supply chain. I wouldn't even call it a link, like an element within a supply chain. Let's say I'm designing a distribution center, a new distribution center. I want to evaluate different types of automation. I might simulate a highly automated solution versus a semi-automated solution to understand the trade-offs between the increased efficiencies and the the effectiveness of that automation. So I might simulate it. In the past, the individual vendors of the automation might actually have that capability to simulate their piece of equipment within the operation of their customers or clients. So the scope was very focused. The math was, while not simplistic, at least straightforward. And the complexity was manageable by the technology at the time. That concept has been expanded and used for larger components of the supply chain. I mentioned the example of distribution centers or manufacturing plants, but the difference is the scope of a digital twin, as we define it in terms of supply chain, is broader than that. It's more end-to-end. It begins certainly at the customer level and works its way back upstream, in many cases, all the way through kind of sources of supply.
I'm curious though, Thomas, when it comes to an actual digital twin, if I am doing that, if I'm using a digital twin to simulate my supply chain, what am I actually looking at on a computer screen? Is it a graphic? Is it a mathematical formula? Is it text? Is it a combination of all the above? How am I actually looking at a simulation of my supply chain digitally?
Yeah, excellent question. And again, that answer has changed over time. In the beginning, you were looking at a two-dimensional, not even a two-dimensional, you were looking at numbers on a page, and doing a lot of math around what those numbers mean in terms of capacity, throughput, service. It evolved to some two-dimensional representation of what the element of supply chain that is being simulated. Two-dimensional, having that two-dimensional image being supplemented with numbers. Eventually it became three-dimensional. So in that example of a piece of automation being simulated, many of the providers of that equipment develop the capability to simulate that in a three-dimensional kind of way. And what we're seeing now is that as the technology advances and the ability to illustrate has also advanced. And so what you're seeing, if you're able to simulate an entire supply chain, is the ability to kind of zoom out and see the entire network functioning and see some level of statistics flowing between 3D representations of each of those nodes of the supply chain, and then the ability to zoom in on any individual one and actually see inside of a warehouse, or of a factory, or even to see a dashboard of supplier diversity, as an example, if that's a key performance indicator. So what you're seeing now is much richer from a visualization standpoint than it has been. And that's also a part of the evolution of digital twinning.
I see. Of course, it's more than just a snapshot. Then you can take it forward and simulate it and see what it looks like going forward, in which case, I guess then you're talking about what some physicists say is the fourth dimension, and that is time. Interesting. Yeah,
Absolutely.
thanks for that.
Absolutely.
So computing power is a big issue when it comes to many aspects of computers today. So I want to ask you, is today's level of computing power enough to power digital twins of entire supply chains?
It is becoming more and more the case. So I would say to answer your question is 90%. We're 90% there.
Okay.
The challenges are not necessarily in the computing power, but in the integration of the information that's got to feed such a digital twin. Is pretty greedy and needy in terms of that information. And more importantly, moving forward, the real value is to be able to keep it current and to use it strategically to evaluate scenarios and do more scenario planning in a go forward kind of way. So integrating that data so that it's refreshing itself automatically that it's connected, that all of it's current, is key. And that's where artificial intelligence also comes into play, because the recognition of certain patterns of performance, it's difficult for a human mind, as complex as it is, to take all of that in and to recognize all the patterns that need to be recognized. And more importantly, to not be distracted by certain patterns that the human mind might notice, but might be insignificant.
Yeah. Yeah. I'm assuming then cloud computing would also be very important to having sufficient computing power. That the advance of that must make it absolutely critical to enable a digital twin. What are, and I think you spoke to this a little bit, Thomas, or quite a bit actually, but I'd just like to get a more specific answer, is just what are the data requirements for a digital twin? What's the input consist of that make it possible to build one of these things?
Yeah. And it's quite complex, but it starts at the center of supply chain and works its way outwards. So the center is always customers, ultimate customers, right? There's some industries that are separated from their customers by, distributors or,
Sure.
representatives that are not, don't give the company direct access. But it starts with intimate knowledge of customers, who they are, where they are, what they buy, and why they buy from, from an individual company, why they buy, from an industry. But beginning with that information, and as I mentioned, the richness of the data, the ability to get into the minds of customers is one reason digital twinning is more possible today. It's becoming, it used to be in the old days, it's difficult to get a demand signal. So not only today is it more possible to get a demand signal, we can also get information about why customers are buying or buying in the way that they're buying, and what their preferences are, and what service means, and what's the difference between same day and next day service, and what are they willing to pay for one versus the other. So that intimacy of customers and the knowledge of what they prefer is the beginning of that data that's got to be shared, and that can be multidimensional, right?
Yeah.
Multiple sources. We're not just talking about point of sale data. We're talking about social media patterns that somehow get translated into insight. But it begins with that and works its way all the way back up the supply chain to some very detailed data, like what are the transportation rates differences between getting something shipped within a day, the same day versus the next day. And if I have 2-day requirement versus 2-week requirement, what is the implication of my supply chain network that's got to provide that? All the information required to be able to estimate, calculate cost, evaluate service is important part of that data puzzle.
Astonishing amount of information in the pre-e-commerce days when it was all brick and mortar retail. It was just, you were lucky to get point of sale information. I mean, that was the big revolution when Walmart started providing point of sale information. And now, of course, it's just ballooned so much. So that's so interesting. But Thomas, what other types of innovations do you think will need to be in place to enable the most effective digital twin?
Great question. And we begin to answer that question in the next webinar series. And I'm looking forward to that one. One of my colleagues will be presenting that. Two of them, one or two of them, Chris Arena. One of those key pieces is going to be advances in what we're calling smart warehousing, meaning that on the floor where an order is actually being fulfilled, the technology exists for that information to be transmitted or shared, communicated up and down the supply chain. I'm thinking about wearable devices that an order picker might have with them as they're picking an order, so that not only are customers getting possible for customers to get real-time updates on the estimated time of arrival of what they've ordered, but they can also see the status of where that order is. Is it, has it been selected? Has it been packaged? Has it been shipped? Where along the path is it? And to be able to transmit that information also back upstream. So, I'm selecting an order and I'm out of stock in a critical item, to be able to communicate that back upstream for the folks responsible for having that item in stock, and also being able to communicate that to those folks who might be taking new orders, who might need updates on that information, so that the estimated time of arrival information that's being communicated to customers is accurate. And sometimes that's a person, sometimes that's a system, sometimes that's a web application that's giving them real-time information about that. But the ability to have smart warehousing technology in place to be able to communicate critical pieces of that puzzle up and down the stream will be important as well. And we're looking forward to that webinar as well, to kind of communicate that.
That's why the interdependency of all these solutions is so great these days. That's why we need 6 episodes of this webinar series in order to tell the whole story.
That's right.
Yeah, thank you very much for that. So do you think that digital twinning will replace small scale simulations, or is there still a role for that type of modeling?
No, I don't think it will replace small scale simulation. There will still be a need for that. In fact, small scale simulations will be components of a digital twin in many cases. But there are instances where even in the absence of a digital twin, these small scale simulations will be important and valuable. Just the ability to model something that's projecting into the future and helping companies better plan strategically, and then to turn those strategies into tactics will still be critically important.
Sure. Thank you very much, Thomas. That's a great points you've made there. And I'd like to move on now to the audience question and answer session. But first, a word from our sponsor, One Network Enterprises. One Network is the leader in supply chain control towers and provider of the AI-driven digital supply chain network. It gives supply chain managers and executives end-to-end visibility and control with one data model and one truth, from raw material to last mile delivery. Powered by NEO, One Network's machine learning and intelligent agent technology, it enables seamless planning and execution across inbound supply, outbound order fulfillment, and logistics, matching demand with available supply in real time. Visit www.onenetwork.com to learn more. And also, don't forget, join us for part 2 of Deloitte's 6-part series on creating resilient supply chains through IT innovation. It's Wednesday, September 28th at noon or 12 p.m. Eastern. The topic will be smart warehousing, incorporating topics such as robotics and automation, sensors and auto ID and blockchain. The speaker will be Chris Riemann, Managing Director of Retail and Consumer Products for Deloitte. With that, then, I want to move to the audience question and answer portion of our presentation. Audience, even as we are answering the questions that have already been submitted, in the time remaining to us, you are encouraged to continue to submit questions by clicking on that Q&A button at the bottom of your screen. So the first question here, and this is probably a good first question because it's kind of a overall, how do I get going with this whole thing? How would you recommend that we start with digital twinning?
Excellent question. And I would point to the answer to a question you asked earlier about smaller scale simulations, and say that one recommended way is just to simulate a component, even if it's small, to begin the process of kind of completely gathering the data, simulating the element, communicating the results, and driving value and demonstrating that. So, if I'm an engineer, industrial engineer working for a company for whom supply chain is important, it's important for me to be able to demonstrate value of the exercise of a simulation or building a model. So I would suggest that a great way is to kind of survey the supply chain of your company, identify the challenges, identify and prioritize those in terms of importance, and evaluate whether or not a model of the element of supply chain can help solve one of those issues. And if it can, start in that small way, demonstrate the value, and build from that.
This question, I think, is in response to the chart you showed us earlier about the difference between current adoption and aspirational adoption of this technology.
Mm.
This questioner is asking if you have any real-world examples of large-scale supply chain digital twinning already.
Another good question. And I will confess that we are at the frontier of the notion of digital twinning for large ecosystems across supply chains. There are some examples. There was a simulation of a postal delivery network, not in the US, but in Europe, that one of my Deloitte colleagues developed. That was pretty broad scale, end to end, meaning kind of started with the delivery of mail and worked its way back up that network. And that model, or I'd say a prototype of that model, designed to kind of evaluate not only kind of facility network opportunities, but also opportunities in terms of labor management, peak labor management, peak service delivery performance. Dashboards came from that as well. That's one example, but I will tell you that this is sort of frontier level work, and there are folks who might call smaller components digital twins, and there really are. But what we're talking about here is more holistic in terms of a whole supply chain being defined as a digital twin.
Thanks. This questioner says or asks, besides data discrepancies, what other factors were preventing digital twinning in the past?
Yeah, the technology itself has been a challenge, and there have been advancements just kind of aligned with the advancements of the improve the efficiency of the microchip. I can recall 30 years ago, I'm aging myself, starting a model, that time not a twin, but a model of a distribution network that had customers simulated and distribution points simulated and factories simulated. And I can recall kicking that model off on the Wednesday before Thanksgiving, thinking that, okay, this thing will be finished on the Friday when I come back. I went back on Friday, it was not finished, still running. So I figured, okay, it'll be finished over the weekend. So came back on Monday, it was still running. And by that Friday, it was still running, and we decided, okay, we need to simplify the model because the math, was just taking too long to optimize. That's just one example. 30 years ago, that same problem would probably be solved today in a 5-minute run. So the advancements in the computing power, is one of the barriers, or one of the reasons that it hasn't been adopted earlier, and really the main reason. And then the second one is the integration of the data. So not just the data itself, but being able to tie it all together, and then to drive that simulation. And then the last reason is because of really the fact that the simulation is really not well understood, even though it's taught. A lot of math involved, high-powered math, but I would say the real art of modeling, modeling is really probably more, 60% science, 40% art. So that 40% art or creativity aspect is what's also been a barrier.
Wow, what an interesting observation, especially since that aspect of art is going to be increasingly taken over by machines in the future. So
Yeah, artificial intelligence.
Yeah, there you go. There you go. This questioner is addressing the often made observation that in reality, a global supply chain does consist of three elements. That is the physical product, the data that goes with it, and the money. They're asking about the idea of a financial supply chain digital twin that would accompany the physical aspect of it. Is that incorporated into digital twins today? And can it be? And what's the future of that?
Excellent insight. And in the digital twins that we're referencing, the money is an integral part of that. So it's one of those three elements, right? So we talked about the merging of the physical to the digital. Without the financial component, the value, of such a model is in question. So it's always a part of what we would define as digital twin. So, the products and the services we talked about flowing through the physical component, flowing through networks or supply chains to get to where they're needed, are typically carry with them some cost, some standard cost to produce it, to package it, to distribute it, and then there's cost to kind of get it to where it needs to be, and there's cost of service as well. So all those components are part of that puzzle, and ultimately, what is the price, and the very extreme end of the supply chain takes into account, the bills of materials that go into producing, each product, and so the buildup of that standard cost is an important part of a digital twin as well.
Throughout multiple tiers of the supply chain, for sure.
Yes.
This questioner, I think, once again, maybe be sort of addressing the difference between the dark bar and the lighter bar in terms of current adoption and future adoption. They're saying the following: I would presume that digital twinning requires exceptional levels of data accounting and integrity, which is still not the case for many, if not the majority of companies. Do you believe that companies can modernize their data practices within the next 5 years in order to make use of digital twinning? If so, what might be the driver or emerging technology to enable that?
Yes, I do believe that's possible. And I've seen the extreme examples of the questioner's question. I've seen, I'm living it every day, really. I can tell you some stories, some data stories, but we do believe that's possible. And the advent of the preponderance of data has driven a lot of advancement in terms of technology to be able to not only collect it and centralize it, cleanse it, and share it. Data concepts like data lakes and but also the technology to be able to harness it and show, and use it as a valuable asset. So, the notion that, data is the new currency is driving a lot of those advancements. So a lot of advancements in business intelligence technology, and the ability to put a dashboard together, and next level of dashboard control tower uh, to be able to harness that information. And the key is to be able to roll it up and down quickly. And the technology exists today to be able to do that. So yes, sometimes I need that base level of detail, which is, requires a humongous effort to kind of get it together and to cleanse it, but also the ability to kind of roll that up quickly, to summarize it for insights, and then to be able to drill back down into the detail where necessary is going to drive those advancements.
I always find it interesting, Thomas, how often a discussion of technology pivots to a discussion of people. And indeed, this questioner is doing that for us. And it's a good question. What technical skills, and I'm assuming they mean what human technical skills, would be needed to work on digital twinning?
Great. So we see this a lot. And part of my work actually goes into factories and distribution centers and helps design processes. And inevitably, one question comes up with the level of automation that is going into these new operations. How could people possibly learn all of that? And my comeback has always been, well, it's easier for them to learn, right? One is because folks are becoming more digitally native, almost digitally comfortable. So even my father-in-law, who is 30 years my senior, has smartphone and iPad, and he's doing banking online, and people are generally becoming more comfortable with digital technology, and that translates into the talent pool, and especially the younger generations are more comfortable with that
Sure.
level. And so I would say it's almost like, just bring yourself. The skills are easily attainable. The learning curves are not as steep. They're less steep, in my opinion, than some of the technology of the past. The notion that I'm going to go and work in a warehouse and have a wearable device that is going to direct me throughout the facility in terms of the most efficient path, those things. Or I'm going to have a cobot that's going to go do some of the heavy walking for me, that's going to work with me in order to fulfill an order. Small examples, but all to say that I believe the talent will not be a bottleneck in advancements.
Good to hear. We are just about out of time. We have time for one final question, and it's a good one to leave us with. Thomas, why is now a good time to explore investing in larger scale digital twinning?
Excellent. So we made the point earlier, and I will go back to it, in that next level supply chain problems, and certainly we are having next level supply chain problems now, but they require next level solutions. And I believe digital twinning is a next level solution. We have learned many lessons through this most recent disruption, and that we're still going through. But one of the things that we've learned is that supply chain is important. It's in the headlines. People understand it more. It's more relatable. And so I believe leaders are in a great position, never been in a better position to actually drive impactful, lasting change, because the importance is clearly in focus. So we're encouraging people to explore the potential power of this next frontier simulation, to be able to simulate and scenario plan around the next disruption, so that we can be more resilient and come back faster and stronger.
Thank you so much, Thomas Boykin, for those great observations about a really exciting technology, digital twinning and optimization. So, Nat, I wanted to thank you, and I want to thank our audience for listening in and for your fantastic questions too. There were lots of them, and those that we did not get to because of time permitting, I'm sure that Thomas would be happy to answer offline. I want to remind everybody, though, to join us for part 2 of Deloitte's 6-part series on creating resilient supply chains through IT innovation. That is on Wednesday, September 28th at noon or 12 p.m. Eastern. The subject will be smart warehousing, as Thomas alluded to earlier, including robotics and automation, sensors and auto ID, and blockchain. The speaker will be Christian Riemann, Managing Director of Retail and Consumer Products for Deloitte. Once again, thank you so much, Thomas Boykin of Deloitte, for that fantastic presentation. Thank you, audience members, for attending and for asking your excellent questions too. We'll see you in September for part 2. Meantime, everybody, have a great day.